Hello, welcome to our channel for probability and statistics. In this video, we will talk about confidence interval of population mean with known variance. So we know if we want to estimate the value of the population, so we usually use the sample mean called x bar because it is centered at the population mean, and in most applications, this variance of x bar is smaller than that of any other estimators of population mean. So we can call x bar is the most efficient statistic estimate for the population mean. And x bar, for one x bar, because if we take many runs of x bar, most probably it will be not same for each run, right? So for the single x bar, it is called the point estimate for the population mean. And when the sample size is sufficiently large, usually at least 30, according to the so-called Central Limit Theorem, so we can expect the sampling distribution of x bar to be approximately normally distributed with the mean equals the population mean and the standard deviation equals the population variance divided by the square root of n. So why we want to know this theorem? Because if we can say it is approximately normally distributed, so we can next use this term, right, to estimate the confidence interval of the population mean. So for the normally distributed variable, we can take the say half alpha. If alpha is 0.05 for a significant level, so say half alpha is say 0.025, right? And this say value is about 1.96 for the normal distribution, for the standard normal distribution. So we can take probability of this standard normal distribution random variable between these two bonds. Probability is 1 minus alpha is 0.95. This is also called a confidence level. So in the large sample case, so we can calculate x bar minus the population mean divided by the population variance divided by square root of n. So where this population mean is what we want to estimate, right? But this form say has standard normal distribution, right? So can write x bar minus mu divided by sigma divided by the square root of n between minus say half alpha and positive say half alpha. This term's probability is 1 minus alpha. So if alpha is 0.05, say half alpha is 1.96. This is minus 1.96 and this is 0.95, right? So in the standard normal distribution density curve, probability of this term is actually the shaded area. So we find, say, half alpha here. So we leave the white area half alpha at both ends of this density curve. So next we can multiply each term in the inequality by this term and subtracting to some mathematical manipulation. We will get this form, the population mean which we want to estimate between x bar minus this term and x bar plus this term, for the probability of this expression is 1 minus alpha. So if we know the sigma for the population variance, population standard deviation, so we can get get the population mean between these two bounds. So these two bounds, the range between these two bounds is also called the confidence interval of the population mean when the population variance is known. So next we will take a look at an example. The average zinc concentration recovered from the sample of measurements taken in 36 different locations in a river is found to be 2.6 grams per milliliter. The question is, find the 95% and 99% confidence intervals for the mean zinc concentration in the river. Assume that the population standard deviation is 0.3 gram per milliliter. So solution is, in this example, the point estimate of the mu is x bar. X bar can be calculated, can be found from the problem is 2.6, right? So the z value leaving an area 0.025 to the right if we want to get the 95% confidence interval, right? So, and an area of 0.975 to the left. So we get this z value is 1.96, which we have shown in previous page. So just fill in these items in the form for the confidence interval. We can get population mean mu is between these two bounds. It's about 2.50 and 2.70 for the confidence interval, 95% confidence interval for the population mean. And for the 99% confidence interval, we have to find another z value, which will leave an area of half of 1%, because 1 minus 99% is 1%, right? So we divide it by 2 is 0.005. And leaving an area is to the right and 0.1995 to the left. So we found that this z value from the standard normal distribution is 2.575. So the 99% confidence interval is, we just put this item z here, then times the standard deviation from the population and divided by square root of population size. Then use the sample mean minus this term and sample mean plus this term. So in the end, we get 99% confidence interval for the population mean is between 2.47 and 2.73. So here you can see for the 99% confidence interval, it is wider than 95% confidence interval, right? This is understandable because when confidence more higher, we must have the higher range. If we have, say, 100% confidence interval, so we can say the population mean is from the negative infinity to the positive infinity, right? This is the same as nothing to be done in the estimation, right? But here we set 99%, 95% is enough confidence. Well, this is a very high level confidence compared with other values. So 95% we can get this confidence interval and 99% this confidence interval. Of course, 99% a little wider because it is a little gross, not so exact to say, right? Say if we want to find the 90% confidence interval, it is much narrower than this one also, of course, right? So just think about it. More wider is more higher confidence. More narrower, more lower confidence, right? But narrower is better. So the best combination is narrower and higher confidence. This is what we want. If we say it's very wide for this mean value, it's nothing to estimate. Because 100% of the confidence we can say from any value on the real number for this mean value, right? So So what we want in estimation for the population is best combination of the confidence level and the narrowness of this range, right? Thanks for watching.